All right, for today's video on lesson 6.2, we will be working with one-step equations. Our essential question for today's video is how do you use one-step equations with rational coefficients to solve problems? We have two vocabulary terms. Our first vocabulary term is coefficient, and we've dealt with this dealing with expressions. By definition, a coefficient is the number that is multiplied by the variable in an algebraic expression. And then we have a second vocabulary term, equation, which many of you have worked with. By definition, equation is a mathematical sentence that shows that two expressions are equivalent or equal. All right, so we have an example here. We have x plus 5 equals 8. So this is an expression. This is as well. This is what makes it an equation. It shows that my left side is equal to my right side. And to solve it, we use inverse operations. So it says essentially we are doing the opposite of what we see. So because I see that I'm adding 5 on the left side, I have to undo it to solve it by doing the opposite, which is subtracting 5. So I subtract 5 on the left, subtract 5 on the right. 8 minus 5 is 3. So down over here, I've got 3 and I have x. And if I put that back into my equation, I would have 3 plus 5, which equals 8. So let's try that here with this one. Here we have x plus 3.2 equals negative 8.5. So I need to undo it by doing the inverse operation of addition, which is subtraction. So I'm going to minus 3.2. And what I do on the left side, you have to do on the right. You have to keep things equal or balanced. So I minus 3.2 on the left and on the right. Bring down my equal sign. Because I've subtracted a 3.2 from the positive 3.2, these cancel out. I'm left with 0. So really I just have x. Negative 8.5 minus 3.2. That is a negative, because since I'm starting with a negative and I'm subtracting, it's like I'm going deeper in the hole. So negative 11.7. So if I tried that back into my equation, negative 11.7 plus a positive 3.2 leaves me with a negative 8.5. Now here, I have a negative 2/3 plus y equals 8. So I need to get rid of this negative 2/3 so that I'm only left with my variable. So if I have a negative 2/3, the only way to get rid of it or leave the value 0 is to have the opposite of it, which is a positive 2/3 or adding 2/3. So if I add 2/3 on the left side, which cancels it out, then I need to add 2/3 on the right side. And 8 plus 2/3, well, that's just 8 2/3. Okay. Now I want you to pause the video right now, and I want you to try these on your own. Alrighty, so 4.9 plus z equals negative 9. So to leave just z alone on the left side, I have to get rid of a positive 4.9 by taking it away. So I'm going to minus 4.9. If I minus 4.9 on the left, I need to minus 4.9 on the right. I'm just left with z equals. Now negative 9 minus 4.9 is a negative 13.9. And then over here, we have something a little different. We know that when we have a number and a variable together with no operational sign, we know that it just means to multiply. So what this is saying is negative 3 times some number equals 36. And the inverse operation of multiplication is division, so that is what I need to do. So I'm going to divide by a negative 3. And negative 3 divided by negative 3 is just 1, or 1c. So I just have c left. Now I need to divide by negative 3 on the right side. 36 divided by negative 3 is a negative 12. Alrighty. Now dealing with one-step equations, we're going to see how that works when we have story problems. How do we write an equation from the information we're given in a story problem? And then how do we solve it? So for this problem, we have an equation working with addition and or subtraction. Amy has some money in her checking account. If she writes a check for $42.50, her checking account will be overdrawn by $23.75. How much money is in Amy's checking account now? So our first step is to write an equation, and I'm going to use the variable x to represent how much she has in her account now, or how much she had in her account. So I've got x, that's how much she had in her account to start with. And we know that she wrote a check for $42.50. So she had some amount in her account. By writing a check, well, that's just taking money out. So I'm going to subtract $42.50. And what that leaves me with is how much is in her checking account. So overdrawn by $23.75. Well, if you're ever overdrawn in your checking account, if you looked at your bank statement, it would look something like this. Negative $23.75. So to solve it, my equation contains subtraction. So the inverse operation I need to use to solve is going to be addition. So we need to add $42.50 to both sides. So negative $23.75 plus $42.50. I know that my answer, because I have more positives than negatives, I know my answer is going to be positive. So because I know that, I can just subtract the two numbers and take the smaller number from the larger number, $23.75. I can't take 5 away from 0, so I need to borrow. Can't take 7 from 4, borrow again. 11 minus 3 is 8, 3 minus 2 is 1, $18.75. So x equals $18.75. And in the context of the problem, what it means is that that's how much she has in her account now. So therefore, she does not have enough money in her account to write a check for $42.50. Turning the page over, we have another story problem in which this one works with multiplication and division. Tyler received a notice from his bank that the balance in his checking account was negative $12, not 0 as he expected. He realized that he forgot to record the time when he used his debit card to buy bus tokens for $1.50 each. how many bus tokens did Tyler buy? So here we are. Step 1, we're going to write our equation, and we're going to use the letter T to represent how many bus tokens he bought. So we know that each bus ticket costs $1.50. So if I bought 2 bus tickets, I would multiply $1.50 times 2. Well, because we don't know how many he bought, that's where this variable comes in. So I'm going to take $1.50 times T, or the number of tickets, and when he bought however many tickets, he spent $12. And we'll make this a negative, which the $1.50, because that's buying or spending $1.50, that would make that $1.50 actually a negative. So here we have our equation. Negative 1.50 times T equals negative 12. So to solve this, once again, we have to use inverse operations. So if our equation contains multiplication, the inverse operation of that is to divide. So I'm going to divide by a negative 1.50. If I do that to my left side, I have to keep things equal or balanced, so I need to do it to my right. Now I know that a negative divided by a negative is a positive, which makes sense because if T is for tickets, you can't buy a negative amount of tickets. So I know that I'm on the right track right now. So negative 12 divided by negative 150. My decimal point. $1.50 does not go into, or 150 does not go into 120, but 150 goes into 1200 8 times. So T is equal to 8, or 8 tickets. Is how many tickets Tyler purchased. Alrighty. Upon stopping the video, I want you to try these 3 questions on your own. Okay, the first one, remember to use those inverse operations. For the second and third one, think about how your equation might look, and then go ahead and solve it. Okay, if you have any questions, jot them down so you can let me know. You can always email me. I will be looking at these 3 questions when you come into class tomorrow.